everyone, we are Group 4 and today we will be presenting about recent progress of fluorescent materials for fingermarks detection in forensic science and anti-counterfeiting. In forensic sciences, fingerprints are unique and most significant physical evidence at the crime spot for identification of the particular person. When a hand comes into contact with an object, the impressions of the rigid patterns of the finger will be left on the surfaces that are touched. In most situations, these finger impressions are undetectable to the human bare eyes and are known as latent fingerprints. Usually, fingerprint topographies are classified into 3 different points, which denote the first, second, and third level. The second and third level of fingerprint traces are valuable and appropriate for specific recognition among these 3 levels, but their characteristics are difficult to establish. Several initiatives were done to examine this fingerprint through physical, chemical, and spectroscopic methods for detecting and viewing latent fingerprints, but their use in forensic science is limited. Therefore, forensic science researchers explore various novel materials and technologies that can evidently imagine and permanently solidify latent fingerprints in a precise, simple, non-destructive, and active routine. Whenever moisture from thumb pores comes into touch with the surface, it forms latent fingerprints. Latent fingerprint moisture glands form ridges designs which are used to create shapes. Various types of perspiration from growing secretion glands, sweat glands, and epithelial glands in the hand, forehead, and face are used to discover latent fingerprints. When elements and chemical substances are present, moisture leaves the most footprints on the hand pore. Each human latent fingerprint is specific and 2 individuals cannot get the same latent fingerprint images. As shown in Figure 1, all fingerprints are divided into 3 classes on the basis of the general patterns, which are loops, arches, and whorls. The magnified images in the figure show specific details such as enclosure, delta, island, and more. Porous, semi-porous, and non-porous are the major, most traditionally classified platforms based on the capability to absorb fingerprint remnants. The acrylic components are rapidly absorbed by porous surfaces, typically in a substance of a few minutes, but the lipid component resolve in the artificial coatings of the platform above many hours. The most frequent porous platforms are cellulosic substances like paper and wood, but inorganic constituents like block, some type of rock, and plasterboard also fall into this group. Non-porous materials like plastic, glass, and metal keep the entire fingerprint solution on the substrate, which dries, settles, and hardens over time. Semi-porous substrates are the most varied and complicated platform category for fingerprint detection because they fall amid the porous and non-porous limits.
Various factors which influence fingerprint, such as nature of substrate, surface, state, age of deposit, or even color of substrate where fingerprint interrupt. Thus, there are so many modern technique detection for the latent fingerprint, such as chemical technique, physical technique, and spectroscopic or mechanical technique. Chemical technique produce latent fingerprint by turning any component of sweat into color derivative. One of the technique is fluorescent dye method. 1,8-diazofluorine 91, or we can call it as DFO, is a fluorescent detection reagent. From this picture, we can see that in the presence of amino acid in latent fingerprint residue, it will result by faint red or under green light, it glow brightly when ninhydrin combining to the DFO. Besides, DFO method need a high temperature and low humidity environment. As for now, this is the ideal technique used for fluorescent generate latent fingerprint on porous surface due to it has a great sensitivity, ease of use, and efficiency. Fingerprint created by physical technique involving physical touch with impression deposit like fine particle scattering or dusting method. Magnetic dust is a common dust used in a crime scene. Fine particle in a fatty or greasy mixture will forming a stickiness that will allow forming of fingerprint. These are pictures show latent fingerprint by powder dusting method on non-porous surface. However, DNA sample may be polluted due to transmission of fingerprint brush. There are so many spectroscopy and mechanical techniques that can be used to identify latent fingerprint on the porous and non-porous surface. For example, GCMS. It can be used to distinguish latent fingerprint fragments such as amino acid or fatty acid. Besides, LCMS can separate and quantify amino acid from latent fingerprint identification. The third one, TLC, that can be used to identify lipid and amino acid compound in latent fingerprint recognition, while the electrophoresis MS can be used for detection and quantifying the amino acid in latent fingerprint remnants. The last one, spectroscopy, fluorescent spectroscopy. It can be used to produce high quality of latent fingerprint recognition picture.
Let's look at the application of nanomaterials in detection of latent fingerprints such as metal oxide nanoparticles, plasmonic nanoparticles, and fluorescent nanoparticles. Metal oxide develop when metal cations react with oxygen, and example of metal oxide are titanium dioxide, zinc oxide, ferric oxide, and aluminium oxide. Most metal oxide nanoparticles are white dyes which improve luminescent efficiency, and it is chemically stable and UV absorbing. Now, let's look at one of the example of metal oxide nanoparticles, which is titanium dioxide. Titanium dioxide is used by spraying method and submission in chemical which help increase fingerprint identification. Titanium dioxide can be applied as an adhesive with a brush to disclose latent fingerprint on both ends of shady colored electrical tapes and duct tapes. Titanium dioxide can be utilized as an adhesive and disseminated as a solution to discover latent fingerprints on both ends of shady colored electrical tapes and duct tapes. It boosts visibility of fingerprints when mixed with fluorescent and organic dyes. Titanium dioxide nanoparticles in methanol, surfactants, detergents will increase blood fingerprint visibility on non-porous, semi-porous, and moist surfaces, but it develops slowly on porous surfaces. By dusting it on non-porous surfaces, it will improve fingerprint-rich image. However, it cannot differentiate between odor and bloody fingerprint. Plasmons are coordinated oscillation of electrical emitters which responds to light. An example is gold nanoparticles. In an acidic environment, gold nanoparticles and fingerprint sweat interact electrostatically. This interaction between negatively charged of gold nanoparticles and the positively charged of fingerprints quickly oxidize and producing visible fingerprint. Due to lipophilic affinity of fatty acid molecules on fingerprint ridge, surface and coamine group of gold nanoparticles easily absorb on fingerprint residues, helping identify and visualize latent fingerprint. This technique demonstrates a lot of advantages. It also allows direct examination of endogenous and exogenous compounds without affecting the fingerprint patterns. This approach also identifies tiny molecules in latent fingerprint. Fluorescent materials such as lanthanide nanoparticles are dusted on latent fingerprints to create high contrast fluorescent signals when exposed to light. Let's look at the application of lanthanide ion doping into UCMP. But what is UCMP? UCMP, or also known as upconversion nanoparticles, are luminous nanoparticles doped with lanthanide ion that produce visible light following near IR excitation. It is used to identify fingerprints because it favors fingerprints materials over the surrounding. The synthesis procedure is crucial as it will alter the UCMPs. The reaction temperature, duration, surfactants, solvents, and starting materials concentration all affect the properties of UCMPs. The advantages is that it can be sensitive and selective, and it can be used on dark background such as dark color handbag. This technique has been successfully applied in the latent fingerprint detection because of its less toxic properties compared to traditional method with high contrast image of various substrates.
In the progress of the topic exists the impact of nanoparticle surface functionalization on latent fingerprints and anti-counterfeiting. The first impact that we can observe are polar or non-polar dispersible nanoparticles demonstrated better availability and clear visualization on latent fingerprint images. This is because various types of polymeric and non-polymeric materials have been utilized. Next is fingerprint created using various procedures display various benefits. That is true and can be consolidated by the better viewing of latent fingerprint on any surfaces compared to other methods, since the technique is novel and durable over time. Aside from that, the surface functionalized nanoparticles have more advantage over nanopowder-based methods, which includes high visualization of ridge and furrows, better performance, clear exposure with great sensitivity, selectivity, and negligible background interruption. Nanoparticle surface functionalization have proven its role as a procedure that is easy to interpret and environmental friendly for ridge detail, especially sebaceous ridge detail. Next, functionalized nanoparticles can be visualized better with our naked eye compared to non-functionalized nanoparticles. This is because it provides a good performance on latent fingerprint images such as excellent ridge details with excellent contrast. We're also able to detect peculiarities in the fingerprint impression for individual identification. This can be seen by utilizing the produced phosphor from the mentioned techniques. Apart from that, recognition approaches is achievable because of its specificity and proper integrity, as surface functionalized protocol is the most unlocking access tool, particularly with ridges and furrows. Lastly, the development of functionalized luminescent or non-luminescent nanoparticles is a novel approach that can produce latent fingerprint images in a simple, quick, precise, non-destructive, and operational mode. Next, the toxicological characteristics of luminescent nanoparticles. First, it can be classified as soluble or insoluble based on physiochemical features. When biological or photochemical degradation occur, soluble nanoparticles may be transformed into molecular byproducts because of the chemical configuration. Next characteristic is metal or fluorescent nanoparticles are insoluble in most solvent except for surface modified nanomolecules. Nanoparticles can cause harm to cellular environment. This is because nanoparticles smaller than 10 nanometer can easily enter into cells, organs, tissue, thus causing damage. Nanoparticles decay in human lungs are very long. It can take up to 700 days for it to decay, posing a persistent hazard to the respiratory system. Other characteristic is toxicity is inversely related to size. Small nanoparticles are more toxic compared to larger nanoparticles. Lastly, luminescent nanoparticles have highly fluorescent nature and display good results in forensic science for detection of latent fingerprint and anti-counterfeiting agents. In conclusion, recent progress of fluorescent material poses great potential because of its outstanding physiochemical properties, including large specific surface area, responsiveness, and durability, which are exploited for fingerprint detection. Various methods have been utilized to create latent fingerprint. To name a few, we have dry powdering, immersion, or spraying of nanoparticles either in solution or in suspension. Depending on nanoparticles, advanced character can be seen under white radiation, UV, or near-infrared light excitation. Many different tools have been used to identify latent fingerprint, which includes Raman, UV-Vis, FTIR, and fluorescence spectrophotometers. As for the future, implementing the use of nanoparticles in forensic research should be widespread, since latent fingerprint are useful physical evidence in court. Further investigation is needed to improve the comprehension of latent fingerprints due to disadvantages of commonly used approaches, such as low improving differences, low sensitivity, and also its toxic nature. Aside from that, we should explore the most modern advancement on fluorescent titanium ion. Thank you.